Hey guys, in this Trek into DIY Tech, we're going to look at the submersible that we've been capturing all the underwater footage with. Actually, we're going to be looking at the controller. We're going to redesign it, and I'm going to show you why here. So I'll show you the submersible first, so you can, in case you haven't seen the other videos, we'll put a link in the link or links in the description below so that you can check those out. So this is the one that's in the I'll just put it up there. This is the one that captured the video of the alligator sitting on the tether. So when I was testing out in the canal, alligator came by and it decided to like settle down right there. Kind of nudged it a little bit to see if it was edible, and it didn't eat it. So I guess it decided it wasn't food. But you can see here, it's just enough space for the action camera to fit in there. We're also using sea perch motors, and the motor controller, or the controller for this submersible, is this, which is it's basically an off-the-shelf sea perch motor, and I've added this here, and what that does is it allows me to put the monitor in there. So let me get the monitor. We'll show you. So it allows me to put this monitor in there, and this is a 2.4 gigahertz. No, I lied. It's a 5 gigahertz. So this is usually for it'll pick up FPV signals and stuff like that, which is going to bring up another question, right? Why am I not using a smaller FPV camera? Or so had the action cameras on hand when I designed that submersible. So I just threw those in there, and I figured I could just plug into the wires that were remaining on this controller. So this controller and this whole setup uses Ethernet cable. That's been working really well. I mean, it's been working really well. If you watch the other videos, you'll see how it gets along pretty well. This is about this is 75 or 100 feet. I forgot. But it's been working really well, and so I kept all of that, and that actually gave us a couple of wires in there. So it's there's 8 conductors in there. We had 2 left over, and I just brought them out this way, and that plugs into there. So I'm not going to go into too much detail on that because there is also a video on the construction of the submersible. So I'll go right into the reason that we're going to redesign this controller, and basically we're going to make a whole new controller. And let me tell you why now. So as you can see on this guy, we used the sourcing materials at your hardware store or grocery store locally. When I did that, I got this foam. You'll recognize is the foam that you use on your pipes to keep the hot water hot and the cold water cold. It didn't work so well, and I kind of suspected this would be the case. So as you dive deeper down into the water, we'll show a little diagram here. Buoyancy, right? So in order for this guy to work properly, it has to be neutral. We have to have neutral buoyancy. This motor actually pushes us down and moves us up. There is no ballast in this thing. We start at the surface, neutral buoyancy, and then actively push this thing down, which is not the best way to do it, but it is the simplest way to do it. So now, yes, the answer is yes. When you go from salt water to fresh water, it does change. So you have to add little weights, in salt water, and remove them in fresh water, and so forth, right? To make it work so that you don't change the floats all the time. Now, what happened? The same thing that happened with the action camera water rig. So I'll also put a link in the description so you can check these videos out. But this one has no motors. So this is the predecessor of the Submersible. This one just has a ballast at the bottom. The float is at the top, and it sinks down. You adjust the length of the rope, and that's where it stays. But this is the thing. When I tested this obviously went all the way down to the bottom, pretty deep in the water. And in one of the videos, you hear some gurgling sounds. I originally thought that the camera case was leaking. That was not the case. You can see this foam is a little bit compressed. As you go further down, the pressure of the water pushes the air out of the cells in this foam. And obvious thing happens. we lose a lot of buoyancy, and then it's a lot harder to come back up. As a matter of fact, in one of the dives, I had to pull it back up by the tether. That's not going to work. Going on to these next few projects, which one of them is we're going to go on we're going to dive on a wreck here pretty soon. Wreck left over from Hurricane Ian. We're gonna take the submersible down and check it out. But before then, we're gonna make a few changes, updates, and so forth. One of them being, this is El Pool Noodle. This one worked. The cells stayed closed, the air stayed in it. That one worked. This one didn't work. But in keeping with the rules of sourcing everything at the hardware store or grocery store, I was able to find some pool noodles. Ironically, there's a at a local hardware store. We're close to the beach, so they carry pool noodles. I bought a bunch of these. We're gonna change all of this out, and then what we're going to do, which brings us back around to the controller. We're going to change the controller, and we have visitors. I'm going to change the controller so that this one just has toggle switches. So it's either motors are either on or off in the direction that it goes. That's obviously not good for cinematography. So you're gonna, as you go further down, and the buoyancy changes, what you practice at the surface doesn't work anymore, and your muscle memory makes it so that this thing starts bouncing up and down. So what we're going to do is we're going to make the new controller, we're going to make it a smarter controller. So we're going to add an Arduino Nano in there. You'll see the rest of the parts. We'll be able to have the Arduino Nano, we'll do a fly-by-wire thing, so we'll just point it in the direction. Arduino Nano is going to figure out how to make this guy move and stay stable. So here we go. So crazy thing, I just wanted to show you guys this. This is a fly-by-wire system for controlling servos on a gimbal. And man, it's 2004. So this is a design I had in 2004. But the reason I wanted to show you this is because the PS2 DualShock controller, I think the joysticks, if I remember correctly, the joysticks are very similar to the ones that we're going to use in this controller design. I'll show you in a second, but I thought that was pretty wild. Obviously now I use the Remarkable instead of a regular notebook. But this is up until a little while ago. I was using the same notebook. But anyway, let's take a look at the parts. And I also found a wireless charger. Maybe we can. No, we're gonna use the monitor. We're not gonna use the a phone as the monitor, because yeah, never mind. We won't use that. Here's so yes, we're gonna use a we're gonna use a sandwich to go snap lock box. So we're gonna use that guy. So as you can see, like trying to hold this as it is with the monitor attached. It's kind of like the weight is a little bit off. So I'm hoping that this, using this as an enclosure, again, we went to local grocery store, got some of the parts for our build. Obviously the electronics we're gonna have to go somewhere else for those. But this is with some modification, as I said before. This box is the standard off-the-shelf controller for the sea perch submersibles, and you see it has the connection there for the Ethernet, because that's what they use. They use the Ethernet cable, and so yeah, I just adopted that so that I could get something in the water pretty quick. You know, I use the sea perch motors and the sea perch controller. But now we're gonna go away from that. Now that we're starting to use this thing more, we're actually gonna finish out that design. So that design is you know, it's very cool for educational purposes and so forth. And we will make another one of these holders for our video monitor. We're probably gonna have to change it so that it comes out from here. We'll see as the design goes. So first thing you want to do is you want to look at the things that you absolutely need to keep, right? So in your design, what are we absolutely going to want to keep? Indicator. This indicator light tells us if there's power, right? So this thing runs off of a 12-volt battery. Typically, you know, I'm using a deep cycle battery to power this whole thing. They're 12-volt motors, so that works out. So we are running off of there. So this tells us, you know, where the battery is, kind of. We need to have the controls, reversible controls for the left and right motors. Left and right thrusters are here. This is up and down. This is the ascent, descent. That controls that motor. So you have two buttons for that, which we're gonna change that. So we need to keep left and right motor control and up and down motor control, and some sort of power indicator. And we also want to keep the video and audio plug going through there. So we want to keep that functionality in there. Everything is still working off the 12 volts. So now we have, you know, requirements, right? So the requirements for the new design. So we want to keep the same functionality. So let's see what we've got in terms of parts. So I have just filled this thing up with parts. Threw all the parts in there. So this is what I was talking about. So yeah, that's a lot of stuff. So what I'm gonna do is we'll go to the controls first. So we'll go in order here. So we have two joystick controllers. So hopefully this is going to give me variable control of the motors. So the further I push it away from center, the faster the motors go. So hopefully that'll give me better control. As you can see in some of the videos, having full on all the time, it makes it very hard to control your movement. And so if I do that for both sides, it'll kind of be kind of like driving a tank or a skid steer kind of situation. So, and then we have the sides. I don't know what we're gonna do with that. You know, maybe we can provide some extra functionality, like these also have a button, if you can see there. When you press the joystick down, it gives you that snap switch there, and maybe we can use that to set the speed. So put it on cruise control, remove it from cruise control. Anyway, that's what we've got there. And this is what I was saying. These are very much like the ones that were in the DualShock controllers. And so now how are we gonna control those motors? give that variable speed. So we're going to have these hooked up to the motors. These are pretty beefy. We're not going to get into the specifics of these. This is an H-bridge controller. So 2 motors will be able to control the left and right speed of the motors through inputs here, outputs here. Power comes in there. Pretty simple devices to use. Again, we'll break off a video maybe for specifically to go into these. And we got 2 of these because, why? Because we've got 3 motors. We have an extra output just in case in the future we need to do something with that, or I don't know, we got an extra output. Always good to have a spare output. So we've got that. All right. So along with that 3rd motor, we're going to pair it up with a slide switch. So this one has a center detent, so I can tell where the center is. So up and down maybe, right? So right now we're just going boof, full on up, full on down, and it makes it, again, very hard to control because as soon as you let go of that switch, right now we don't have a way to actively control how much ballast is in there, right? So we're not pumping air in and out or pumping water in and out to compress the air and the ballast and all of that. So that as soon as you let that switch go in its current configuration for the controller, that ROV just like pops up, or if you press the switch and you don't have enough, it just drops it real quick. So it's kind of hard to get it to sit in that proper position. So I figure maybe we have a way to select, how much the motor's spinning in this neutral position, right? So change the reference speed for the motor when it's in the water, and then when you want to go, you want to bring it up a little bit, you can do that and slowly bring it up and then center it back. So we'll see. We'll see how all of that works. I think we have the caps for this too, so it'll be really nice in there. So that's going to go with that guy. We have the audio jack. This time I'm not going to have just the wire, just the plug just coming out. I'm going to have a cable go between the two, right, with two jacks on it, kind of like this. I'll get a shorter one because I don't need all that much. But that stereo jack will be able to plug into here, and then we'll be able to plug this other end into the monitor, and then we'll do it that way instead of just having the cable coming out of the box. We'll be able to unplug this cable in case we want to use a different cable, right? So a little bit of improvement while we're at it. We'll put that in there. So we've got that. Arduino. I haven't soldered the pins on the Nano. Sorry, so you're not gonna see this plugged in, but we'll show you what that looks like. So this is the Trek pack for Arduino. So this is gonna be in our store, but here it is. So this is how this guy works. You just plug the Nano in there, and then it lets you put jumpers right in there. It's very compact, so I like this one. It saves me a lot of space in the enclosures. So we've got that. Make a little more space over here. All right, so instead of that LED, we're actually gonna have a battery meter in there. So nice old school decimal battery meter there. Lines would be cool too, but the battery level lines, yeah. But I think this will give it a cool look to have, kind of like the kit dashboard from Knight Rider back in the day, right? So, oh man, I just dated myself. I'm sorry. All right, so this is another the DC in plug, same exact one that's in the current controller. So we can use the same cable that we use to go to the battery, and again, we'll be able to disconnect the cables from the controller in case I have to work on the controller separately. I don't want all that cable. Power switch. I forgot this is a nice one. This is a nice high amperage power switch. Rocker switch, right?
off the shelf. This, I got this at automotive shop a long time ago. I don't even remember. This has been in those bins for a very long time. And since we have the Arduino Nano in there, we'll be able to provide some audio output. So this is a waterproof, although this case is not going to be, so the case is waterproof, but we're going to make holes in it and the joysticks are going to go through. It's not really going to be waterproof. It'll be splash proof. But if you seal around here, it makes, this is a waterproof, and you can see 8 ohm, 0.4 watts. Yeah, it's pretty good. Pretty hefty. We can put this in there and we'll have some audio output. So we can set up some warnings or a little bit more functionality in the same in the box. You know, since we have a little brain going in there, we can do that. And almost last but not least, we're gonna have ourselves an OLED screen in here. So what that's going to give us is we're going to be able to see, what the speed of the motors are currently, maybe some amperage. We'll put a module in there to read the amperage, so we can see how much power we're using. We can just we'll have a way to change what displays on here. So maybe we'll have a little button there. Maybe the functions can be on the joystick itself. We'll see, right? We're programming the thing, so we can basically do whatever we would like on there. And so that'll be nice having that on there. So we'll put it back in the protective case. And the last thing that we're going to have on there, so on the back, I didn't want to just make a hole here or try to 3D print something to go in there to accept the Ethernet cable, right? And in the spirit of picking everything up at the hardware store and or your grocery store, these are available at the hardware store. Surface mount Ethernet jack. So we're going to take advantage of that. Wow, brand new. We're popping it open. Be careful with the staples. So here we go. These are really cool. I've used these before, not so much in recent times because these days everything is wireless these days. So we really don't have to. Your Wi-Fi, right? You don't have to plug your you don't have to plug your computer into the wall, and in many years it has been. But these are cool because it's got a couple of screw holes there. Maybe we can use some double-sided tape for now while we're finalizing everything. But what I'm going to do, and this will provide a really cool, we'll put it right there. We'll run the wires through, and nice little connection points there. So as we're working things out, we connect, disconnect, whatever. But the Ethernet cable will be able to plug right into there. Boom, right there. And then we'll, same as the other controller, we'll be able to disconnect. And it kind of gives me a reference point for where my fingers are. See, that works out pretty nice. This is the first time, I'll be honest, this is the first time I've had it on here like this. So I didn't know how that was going to feel, but that's pretty cool because like sometimes I'm filming and I take my hands off and you kind of lose track of where your hands are, but this is going to provide a nice feedback for that. So I can do this and hold it like so, and then that'll also tell me where to put my joysticks right here. So that has a really good feel to it. I don't know, smaller hands might be different for smaller hands, but that has a really decent feel to me right there. So that's what we're gonna do. So now now that we have everything almost where it's laid out, so now that we know what parts are gonna be in there, what we're gonna do is we're gonna go ahead and sketch this out, roundabouts where the parts are gonna be. So now you guys know, like when I do stuff for work, I break out the CAD and measure 3, 4, 5, 6 times and do all of that. But you know, for this project, what we're gonna do is we're probably gonna put masking tape on here. After I finish sketching everything out where everything's gonna be, we're gonna go ahead and put some masking tape on both sides of this. Actually, draw it out on the surface of there and start drilling and cutting and doing all that. So here we go. Next phase. All right. So we have to move this whole thing inside because I don't know if you guys might have noticed there were some droplets of liquid falling on the bench, and I gotta confess that was my sweat coming down. So when we it is so hot in the lab that when I turn off the fans, I turn off the fan and the AC in order to get good audio recording. It gets hot real quick these days. So we're going to do this inside the house. And so, yeah, brought everything with us. We're going to take this. So we're going to keep this here as a reference. We're going to go ahead and pull this out since we know that goes on the back. That's only one place that can go. So that's going to go, we're going to put this aside for now, as well as the adhesive that goes with it. We'll put that aside. We'll separate this into 2 sets of parts. And we're also going to make another change. So I decide I'm going to go point-to-point wiring on this one. So we're going to ditch the headers to save us a little time, little space. We're going to ditch the headers, which gives us that amount of thickness there. I'm going to solder the Nano directly to here, and then solder point-to-point wiring. We're going to solder directly to these right there. So we're gonna make that substitution there. And again, these are available on the website. You guys can pick these up if you want to get one of these on our online store. So we're gonna separate this into 2 sets of parts. The parts that go on the cover, on the front cover. I think I want the audio facing me. We could put the audio on the back of that so it comes out of there. Maybe that would be interesting. Audio comes out of here, but then it's stuck to the cover. No. See, these are the design choices you have to make. We will still have this coming out of the back, so we'll put it with screen goes here. Power switch. I think I want the power switch on top so I can, in case there's an emergency, I can work it from the top. This will go on this side like it is in the original. So we'll put that out of the side as it is here. This is obviously, we're going to put the power coming out of the bottom. So this is taking shape already. This one goes in the top, in the top, in the top. So now we have the parts that go in the top, the parts that go in the bottom. So I'm thinking we can do this with these guys. We're going to have standoffs for this. So this could potentially go right over where that little speaker is, or we can move the speaker down a bit. So if you can see this line down here, that's the line. We're trying to stay inside of this line such that, again, so that, the screws, when we put screws on this, all of this is going to be on standoffs and or spacers or washers. So that looks good to me. The wires will come out, go right into the box at the back. So this is our target back there. So we have to be careful. We can run the wires under this guy. So this guy, screw placement, that's nice. We can get away with that. So we can definitely put that guy there. Put this guy down here up against the bottom there. This will give us a little space. Run the wires right to the Arduino. I look good. Looks good. Looks good. Or we can offset this. This is my own brain, right? And these are going to come through the top, so we can lay these out here like so. And then that gives us enough space in the middle to put this in the cover. So if we close this down, let's see if it closes down over there. It does. Okay, that's awesome. So we can go ahead and sketch that out that way. We can put the power meter at the bottom, indicating that it's coming up through the bottom. So we'll mount this from the back face of this, so that this shines through that. And then what we're going to do is we're gonna put the screen there. Man, maybe we do put the audio like, no, sorry. Where are we gonna put this? So let's grasp this in our hands. So if we hold it, okay, so that's gonna be there. So how do I work the up and down? This will be maybe counterintuitive if I put it up, down, no, maybe not. We can even put it at an angle, or we can put it down here so that I don't, that's too far. There we go. That feels good right there. So, and then we can move that up and put the power switch there. So that gives us a little space here. Maybe we put some other control there later, but that looks really good. That looks really, really good. So at this point, what I would typically do, this leg is messed up, so it won't stand. What I would typically do is I would, I'm going to give up on that. So that's nice. Yeah, that feels good. Surfacing down. And yeah, that feels really nice. Okay, so what I'm going to do now is, now that I have all of that laid out, I'm going to sketch this out so that we have a record of where everything goes. And I think there's enough space even down here. Yeah, there's enough space to put that connector down there, as well as the connector in here. There's enough thickness there, I believe. Yep, that can go right under there. Even if we have to notch this out, we may have to notch out this but let's draw the top. Let's draw the top and inside locations for everything, and then we'll look at the sides. So this will go here. This will go here. Thank you, Mr. Reference. We'll move you aside as well. All right, so let's do some sketching here. Oh, my joystick's moved. Leaned it back and the joystick's moved. But that's, yeah. We'll sketch out the relative locations of everything there. Hey. All right, here we go. This is the cool part. We get to mess around with different designs and stuff. So let's pick a dots template. No, maybe a grid. Yeah, we'll go for a grid this time. Medium grid. So this basically is going to be 2 squares. So let's just put 2 squares out there. How big do we? Big enough for me to see, because I'm a little blind. I am going to make the front and back layout roughly with this. So when, like I said before, when we actually do this, what we're going to do is we're going to put tape across both faces, and then we'll actually make the measurements for all the holes and everything. So these are, I think these are 256, 256. This is 440. No, these might be 2 as well. It looks like a small screw, so that might be 2 as well. I know the other boards in there are all 440s. So let's do the the top here. And so we're gonna set the joysticks here. Set the joysticks there. We'll put the Arduino Nano. And I'm doing this backwards because I'm looking through the top. Really what I should do is, oh no, I did mess up. Okay, so that's okay. That's all right because we can do this. Oh, I didn't capture everything. Go back. I did not capture everything, so make sure I make a big enough lasso around this. Oops. Okay, hopefully I got everything. Yep, I got everything. So we'll move these to here. So this is it. We'll do the bottom here. So bottom, bikini bottom. For those of you who watch SpongeBob, I'm sorry. Yes, I have two boys. So yeah, we will make this match. Okay, so cool. Oh no, why did I do that? There you go. All right, so we're gonna put the OLED screen here. Oh, switch back. We're gonna put the OLED screen here. We'll put the OLED screen here. We'll put the battery meter there as we have it. Power switch, the power switch in the center. We'll make it left right. So we'll turn that guy 90 degrees. We'll make it a left right thing here. And maybe we'll still put an LED here somewhere, just to give us some nostalgic. And maybe we'll make it an RGB LED to give us a good indication of. I don't know. We can use some extra functionality. You can always use some extra functionality. And then we will put the slider for the up and down here as it is there. And so you get the idea. I'm going to finish off the rest of this. We'll probably speed it up a little bit so that we can get to the sides and look and see how that's going to go. So yeah, we'll speed it up from here. Now, the other thing that I wanted to do now that we have all of that laid out is check and see where we can put the connectors for the power and the audio, or the video, I should say. Their audio does come through because the cameras do pick it up, and the cable that's in there, I think we have enough cables for audio. Anyway, in either case, one of the main reasons that I have those action cameras in there instead of the FPV and all that, because it's easy to have the cameras record, and then you can take it off the SD card. So you can take it straight off of the SD card. So now, let's see, we're going to make the outside look of this. This is very messy because I'm drawing from way back here, so I can get the camera in here. But so this is the outside of the enclosure, and so we're gonna put the power jack is going to be here. And it's going to be in the bottom half of the clamshell. So let's check that out. So it looks like there's just enough space there, but what we're going to have to do is we're going to have to notch this out a bit. It won't affect, it's not a high pressure thing, so we're not going to affect the functionality of this too much. We're just going to notch that out so we can get this in there. This is a very small, doesn't have to be much, because it doesn't, the jack that goes in here it's not really bigger than the outside of that. So we just have to make a small notch for that. We just take a file and do that. So that's in, we'll keep that there. And then this one shouldn't be a problem at all. So, because this one is going to go up in the corner, so it's going to miss that latch completely. This one can go right here, right on that flat spot. And that plug also is not bigger than that diameter, so that can go right there. And that'll work out really nicely. So yeah, that's it. So we have, let me label this. So we have everything we need now to go on to the next step, which is starting to build this thing. And when you see this next, it'll have blue tape all over it, and we'll start marking everything off. And we'll use some official measuring device so that we get the joysticks more or less in the same spot on both sides from the corners, and so on and so forth. So there you go. We've got this top, bottom plates, and position of the connectors that come out to the outside. So we can even add this box in there. And we make sure we annotate that this box goes on the backside. There you go. And usually if you do this in a drawing, what you would do is, since it's obscured, from the front, what you would do is you would make a dotted line so that you would know that it's not visible from the front. But that's it. There you go. We have everything we need there. Alright guys, now that we have the design done,
Next video is going to be the build video. So I split them up into 2 videos because otherwise this video would get really long. So we're done with the design part of it. Next video is the build video. Hey, I know it's hard to get to the end of these videos. So as always, I really appreciate the time you spend with me, and we'll see you in the next video.